minus 8. So just we use normal method, that 2 into 8 minus 2 into minus 8, that is 16, minus 6 into 3, that is 18, plus 1 into 4 into minus 8, that is minus 32, minus 6 into minus 6, that is plus 36, plus 3 into 12 plus minus 12, that is equal to 0, because 16 minus 18, that is minus 6 into 2, that is minus 12, plus minus 16 into 16 minus 18, that is minus 2, minus 2 into 2, that is minus 4, plus 4, minus 32 plus 36, that is plus 4. So minus 4 plus 4 plus 0, that is equal to 0. Hence the rank of A is not 3, because you will get determinant of this matrix is equal to 0. Now just take any 2 cross 2 determinant from this matrix. So that means what? You can take minor of any element. So totally how many minors you have? 9 minors, right? That means because you have 9 elements, so you have to check each minor such that determinant of that minor is not equal to 0, right? So starting with the first minor 2, we want to find the minor of the first element 2, that is equal to determinant minus 2 6 3 minus 8, minus 2 6 3 minus 8. Okay, let's take minor of 2, that is equal to minus 2 6 3 minus 8, that is equal to 16 minus 18, that is equal to minus 2, not equal to 0. So that's why rank of A is equal to 2. That's why rank of A, that is equal to 2. If suppose the determinant of this minor of 2, right, that means if minor of 2 is equal to 0, then we have to consider some another minor of another element, right? We have to consider minor of some another element. If suppose that is equal to 0, then again we have to take minor of some another element. So total 9 minors you will get. If suppose from that 9 minors, if one minor is not equal to 0, then definitely rank of A is equal to 2. Okay, but just we take first minor and that is not equal to 0, so you can say that rank of A is equal to 2. You don't need to check another minor. Okay, you don't need to check the minor of another elements, right? So here is a solution of this questions. Next question 1c, third part. Is 0 0 0 0, that means 0 matrix in 2 cross 2 matrix, is in row echelon form or reduced row echelon form? That is a question. This question asking only just 1 marks, and the answer is definitely the 0 matrix is in reduced row echelon form. Why it is in reduced row echelon form? Just try to remember what are the conditions to become a row echelon form or reduced row echelon form. First of all, you have leading entry. The main thing is that definitely you have leading entry, and all the conditions are depending upon the leading entry. I repeat, all the conditions, that leading entry, below that leading entry all the elements are 0, right? Leading entry means what? Non-zero element. Definitely leading entry is non-zero element, right? So all the conditions are depending upon the leading entry. If you have leading entry, below that leading entry all the elements should be 0. Whenever we are going from top to bottom, the leading entry is going from left to right, right? Whenever if there is any 0 row, it should be the bottom of the matrix, right? In the another 2 conditions to become a reduced row echelon form, that is leading entry is must be 1 if there is such column in which that leading if there is such column in which they have leading entry, in that column except that leading entry all the elements should be 0, except that leading entry all the elements should be 0. Okay, so except that leading entry all the elements should be 0. So this all the conditions are depending upon the leading entry, but if you don't have any leading entry, that means what? All the conditions are automatically satisfied. Exactly that thing happen in this matrix. in this 2 cross 2 matrix. We don't have any leading entry, because leading entry means what? Leading entry is definitely non-zero element, but we don't have any non-zero element in this matrix. So means all the conditions are automatically satisfied. So that's why you can say that this matrix is in reduced row echelon form, and definitely this matrix is in reduced row echelon form, means that is also in row echelon form. Okay, so it is row echelon form and reduced row echelon form both. Okay, so just try to understand carefully. Next question, question 2a. Question 2a, first part. What conditions must b1, b2 and b3 satisfy in order for x1 plus 2x2 plus 3x3 that is equal to b1, 2x1 plus 5x2 plus 3x3 that is equal to b2, x1 plus 8x3 that is equal to b3 to be constant, to be consistent, sorry, not to be constant, to be consistent. Okay, consistent means the solution is exist, right? So is there any conditions to system to solve this system of linear equations, so that we can solve this system of linear equation? So that we have to find. Okay, so the matrix equation, just solve this example with our normal method. We have to write down the augmented matrix. That augmented matrix we have to convert into a row echelon form, and just see what happened then. Okay, the matrix equation of the given system of equation is 1 2 3. The first row is the exactly the solution, exactly the coefficient of x1, x2, x3 from the first equation, that is 1 2 3. Then the second row is from the second equation, that is 2 5 3. Third row is from the third equation, that is 1 8 1 0 8. Okay, coefficient of x1, x2, x3. X1 then so matrix is 1 2 3 2 5 3 1 0 8 into x1, x2, x3, that is equal to b1, b2, b3. So the augmented matrix is, here is our augmented matrix, 1 2 3 b1, 2 5 3 b2, 1 0 8 b3. So now to convert this matrix into a row echelon form, what we have to do? First we are trying to convert this matrix into a row echelon form. So we are multiply first row with -2 and add into the second row. So the first row is as it is, and the 1 2 3 b1. Second row become 2 minus 2 0, 5 minus 4 1, 3 minus 6 minus 3, b2 minus 2 b1, right? b2 minus 2 b1. And next process is we multiply first row with -1 and add into the third row. So the third row become 1 minus 1 0, 0 minus 2 minus 2, 8 minus 3 5, and b3 minus b1, b3 minus b1. Okay, next process we multiply. Now in first column we have leading entry 1, below that leading entry we have 0. In second column we have leading entry, in second row we have leading entry 1, below that leading entry I won't make there 0. So that's why we multiply second row with 2 and add into the third row. So the second row become so second row, first and second row are as it is, 1 2 3 b1. You can see 0 1 minus 3 b2 minus 2 b1. The third row become 0 minus 2 0, then minus 2 plus 2, that is 0, 5 minus 3 into 2, okay, that is minus 1, and then 2 b1 plus b3, 2 b1 plus b3 minus 5 b1. Okay, so here rank of A is equal to 3 and rank of A gem B augmented matrix, that is also 3. So no conditions is required on b1, b2, b3 in order for the given equations to be consistent, because rank of both the matrix have same, rank of A and rank of A gem B, that both have same. Okay, so that's why no conditions is required on b1, b2, b3 in order for the given equations to be consistent. Okay, question 2a, second part, is T from R3 to R3 defined by T of xyz, that is equal to, the first coordinate is x plus 3y, second coordinate is y, third coordinate is z plus 2x. Is it linear? That is the first question. Is it 1 1 and on 2 or both? Justify. So we have to check linearity, one-oneness and onto-ness, right? So what is the definition for linear transformation? That you should know. If T is a transformation, right, from Rn to Rm, or in general vector space T is a transformation from V to W. To check that T is a linear transformation, what we have to do? We have to check, first of all, we have to check two conditions, T of x plus y. T of x plus y, that is equal to T of x plus T of y. Second condition is T of alpha into x, that is equal to alpha into T of x. Okay. So T of x, let take x is equal to simply ABC and y is equal to PQR. Let's take x is equal to ABC and y is equal to PQR. So T of x is equal to T of ABC, and so from the definition you will get T of ABC is equal to a plus 3b, b, c plus 2a. Okay. T of y is equal to T of PQR, that is equal to p plus 3q, q r plus 2p, right? So T of x, now from starting from the LHS, T of, now what is x plus y? X plus y is a plus p, b plus q and c plus r. So T of x plus y, that is T of a plus p, b plus q, c plus r, that is equal to a plus p plus 3 into b plus q, comma b plus q, comma in bracket c plus r plus 2 into a plus p. So that is equal to a plus 3b, b, c plus 2a plus p plus 3q, q, r plus 2p, that is equal to T of x plus T of y. So T of alpha into x, that is equal to T of alpha a, alpha b, alpha c, right? That is equal to alpha a plus 3 into alpha b, alpha c plus 2 into alpha a, that is equal to alpha into a plus 3b, b, c plus 2a, that is equal to alpha into T of x. So we satisfied both the conditions for linearity, right? T of x plus y, you will you get T of x plus y, that is equal to T of x plus T of y, and also you get T of alpha into x, that is equal to alpha into Tx, right? So both the conditions are satisfied, so that's why T is a linear. Now next is you have to check T is 1-1 or onto or both. So for one-oneness, what you have to do? You have to starting from T of x is equal to T of y and try to prove that x is equal to y, right? So we are starting from T of x is equal to T of y, that is equal to a plus 3b, b, c plus 2a, p plus 3q, q, r plus 2p, that is equal to a plus p, b is equal to q and c is equal to r. So definitely x is equal to y, okay, and so T is 1-1. Now let z is equal to, now to onto-ness, what we have to do? To onto-ness, let z is equal to z1, z2, z3 belongs to R3, then x is equal to z1 minus 3z2, take x is equal to z1 minus 3z2, z2, and then minus 2z1 plus 6z2 plus z3 belongs to R3 such that T of x is equal to z1, z2, z3. If you want to check just this x into the definitions, T of x, what is T of x? T of x y z is x plus 3y, y z plus 2x. So x plus 3y means what? First coordinate plus 3 into second coordinate. So when you put x in this definition, so you will get T of z1 minus 3z2, that is equal to z1 minus 3z2 plus 3 into z1 minus 3z2 plus 3 into z2, that is equal to z1. So definitely first coordinate are satisfied, okay. So this question paper up to we see question number 2. So thank you.